In question 1, a curve has equation y equals to 2x power 3 upon 2 minus 3x minus 4x power 1 upon 2 plus 4. We have to find the equation of the tangent to the curve at the point 4, comma 0. Now, to find the equation of the tangent, we'll need the gradient of the tangent and a point. We already have the point, which is 4, comma 0. Now, to find the gradient, we'll find the dy dx of the curve. So, in the first step, finding the dy dx, which will represent the gradient or the gradient of the tangent. So this will become 3 upon 2 multiplied by 2. So 3 upon 2 multiplied by 2 will become 3x, and decreasing the power by 1. So that will become 1 upon 2 minus differentiating 3x, that will become 3. Taking the derivative of 4x to the power half. So half into 4 is 2, and this will become 2x to the power minus 1 upon 2, and differentiating 4, that will become 0. We can simplify it to write it as 3 into square root of x minus 3 minus 2 upon square root of x. Now substituting the value of x, so that the value of x is equals to 4. So substituting x equals to 4 to the equation, we'll get 3 into square root of 4 minus 3 minus 2 upon square root of 4. So this will become 3 times 2, which is 6, minus 3 minus 2 upon 2. So 2 upon 2 will become 1. We'll get 6 minus 3 minus 1. So that will be equals to 2. Once we have the gradient of the tangent, which is equals to 2, we can now find the equation of the tangent by using the formula y minus y1 is equals to m into x minus x1. So the y1 coordinate is y minus 0, with the gradient is 2, and the x coordinate is x equals to positive 4. So the equation will be y equals to 2x minus 8 for the equation of the tangent. In question 2, a function f is defined by f of x equals to x cubed minus x squared minus 8x plus 5 for x is less than a. It is given that f is an increasing function. We have to find the largest possible value of the constant a. Now, for f to be an increasing function, it means that the dy dx will be greater than 0. So in the first step, finding the dy dx, that will be equals to, so dy dx will be equals to 3x squared minus 2x minus 8. Now substituting dy dx is 0 in the first step, we'll get 0 equals to 3x squared minus 2x minus 8. Factorizing this, we'll get 3x squared minus 6x plus 4x minus 8 equals to 0. Taking 3x common, this will be x minus 2, plus taking 4 common, this will be x minus 2 equals to 0. We'll get 3x plus 4 and x minus 2 equals to 0. So the two values of x will be x equals to 2 and x equals to minus 4 upon 3. Now, as dy dx has to be greater than 0, first we will draw a quadratic curve and then apply the inequality signs. Now, this coordinate will be x equals to 2 and this coordinate will be x equals to minus 4 upon 3. As dy dx is equals to 0, it means x has to be more than 2. So x has to be greater than 2 and less than minus 4 upon 3, as this is the positive part of the curve and this is the negative part. And as dy dx has to be more than 0, it means that it has to be above this x-axis line. So the other inequality will be x is less than minus 4 upon 3. Now, as the question said that for x is less than a, it means that the largest value that a can take or x can take will be equals to minus 4 upon 3. So a will be equals to minus 4 upon 3. In question 3, a geometric progression has first term 3a and the common ratio r. A second geometric progression has first term a and common ratio minus 2r. The two progressions have the same sum to infinity. We have to find the value of r. Now we know that the formula for sum to infinity is given by a upon 1 minus r. So finding the sum to infinity of the first progression, we can write it as, so the first term is a, so 3a, so we write it as 3a upon 1 minus r. The second progression has the first term of a and a common ratio of minus 2r. So that will become 1 minus minus 2r. We can cancel out the a's. So cross multiplying, we'll get 3 into 1 and this will become plus 2r equals to 1 minus r multiplied by 1. So that will be 1 minus r. Opening the brackets, we'll get 3 plus 6r equals to 1 minus r. Taking r on the other side, that will become 6r plus r equals to 1 minus 3. So 7r will be equals to minus 2, and the value of r will be equals to minus 2 upon 7. In part B, the first two terms of an arithmetic progression are 15 and 19. The first two terms of a second arithmetic progression are 420 and 415. The two progressions have the same sum of the first n terms. We have to find the value of n. Now, for the first progression, as the first two terms are 15 and 19, so we can say that a is equals to 15, and the common difference is the difference of the of two consecutive terms. So that will become 19 minus 15, which is equals to positive 4. For the second progression, the first term is 420 and the second term is 415. So the common difference will be 415 minus 420, which will be equals to minus 5. Now, as they both have the same sum of the first n terms, the formula for sum of n terms is n upon 2 into 2a plus n minus 1 into d. So substituting the values of a and d into the equation for the first progression, so we'll leave n as it is. This will become n upon 2 in bracket 2 into a, which is 15, plus n minus 1 into d. So that the common difference for the first progression was 4, and it will be equals to the sum of the n terms of the second progression. So for the second progression, this will be n upon 2 into 2a. A is 420 plus n minus 1, and the common difference is minus 5. So n upon 2 and upon 2 on both sides will cancel out. This will become 330 plus 4n minus 4. 420 into 2 is 840. This will become, so minus 5 into minus 1 will become a plus 5, and minus 5 into n will become a minus 5n. Taking 5n on the other side, that will be 4n plus 5n is equals to 845. So 845 and 30 minus 4 is 26. So that will be 845 minus 26. 9n will be equals to, so 845 minus 826 will be 819. So n will be 819 divided by 9. So the value of n will be equals to 91. Question 4. Machines in a factory make cardboard cones of base radius r and vertical height h. The volume of such a cone is given by V equals to 1 upon 3 pi r square h. The machine produces cone for which h plus r equals to 18. In part 1, we have to show that V equals to 6 pi r square minus 1 upon 3 pi r cube. Now, as we can see in this expression, there is no h, and originally V was equals to 1 upon 3 pi r square h. So we can take the substitution, which is h equals to 18 minus r. So substituting h equals to 18 minus r, we get 1 upon 3 into pi r squared into 18 minus r. Multiplying by 18 minus r, 1 upon 3 pi r squared. So that will become 18 pi r squared upon 3 minus pi r cubed upon 3. Simplifying this, we'll get 6 pi r squared minus 1 upon 3. So v will be equals to 6 pi r squared minus pi r cube upon 3, as the same expression that we had to prove v equals to 6 pi r square minus pi r cube upon 3. In part 2, it says, given that r can vary, find the non-zero value of r for which v has a stationary value and show that the stationary value is the maximum. Now, to find a stationary value, it means that we'll first have to differentiate the expression and put it equals to 0. So as v was equals to 6 pi r squared minus pi r cube upon 3. First differentiating, so we'll write dv upon dr will be equals to, so 2 multiplied by 6 will become 12 pi r, 3 multiplied by pi will become 3 pi, will decrease the power by 1, so that will become a whole square upon 3. 3 and 3 will cancel. So this will be 12 pi r minus pi r squared will be the expression for dv by dr. Now, as it is talking about a stationary value, it means we will equate it to 0. dv dr will be equals to 0. So 12 pi r minus pi r squared will be equals to 0. Simplifying, we'll get pi r squared equals to 12 pi. And now cancelling pi's on both sides, you'll get r square is equals to 12. So this is 12 pi r. So you'll get r square is equals to 12r. So r will be equals to positive 12. Now we have to prove that it is a maximum value. So to prove it is a maximum value, we'll differentiate the expression for dv by dr in the first step. So finding dv square d upon dr square. So this 2 will be up here. This is written as d square v upon dr square. That will be equals to, so differentiating the expression for dv by dr, we'll get 12 pi minus 2 pi r. Now substituting r equals to 12, we'll get 12 pi minus 2 into pi into 12. So that will be 12 pi minus 24 pi. Now as this value is a negative, 12 pi minus 24 pi will be equals to minus 12 pi. As it is less than 0, it proves that this is a maximum value. In part 3, we have to find the maximum volume of the cone that can be made by these machines. Now to find the maximum value, we already have the maximum value of r, which was r equals to 12. And the expression for v was 6 pi r squared minus pi r cube upon 3. So v was equals to 6 pi r squared minus pi r cube upon 3. Or we can use the expression 1 upon 3 pi r square h. So substituting r equals to 12 into this expression, we'll get v equals to 6 pi into, so this will become r squared, which is 12. So this will be 12 squared minus pi into 12 cube upon 3. So 12 square will become 144 into 6 pi minus 12 cube. So 12 cube is equals to 1728. So that will become 1728 pi upon 3. 1728 divided by 3 is 576. So V will be equals to 144 into 6 minus 1728 upon 3. So 144 multiplied by 6 is 864. 864 pi minus 1728 divided by 3 was equals to 576 pi. Subtracting these answers. So 864 minus 876 will be equals to 864 minus 576 is equals to 288. So the final answer for V will be equals to 288 pi. In question 5, the diagram shows an isosceles triangle ABC in which AC equals to 16, AB equals to BC, which is equals to 10. The circular arcs BE and BDF centers A and C respectively, where D and E lie on AC. In part 1, we have to show that angle BAC equals to 6.435 radians, correct to 4 decimal place. Now to find the angle BAC, which is this angle, we can either use the cosine rule, as we have all the 3 lengths given in the triangle, or as it is an isosceles triangle, we can make a straight perpendicular line from B till the line AC. And as it is an isosceles triangle, so it will be exactly in the middle, which means that this length, let's call this point X, will be AX will be equals to 8 centimeters, half of 16. So to find the angle BAC, we can use cos theta. So cos of BAC will be equals to 8 upon 10. So BAC will be cos inverse of 8 upon 10. Taking cos inverse of 8 upon 10, the angle BAC will be equals to 0.6435 radians. In part 2, we have to find the area of the shaded region. Now to find the area of the shaded region, we can first find the area of the sector ABE, then find the area of this triangle ABX, as we already know that this angle will be 0.6435 radians, and then subtract the area, which will give us half of the area of the shaded region BXC, and then we can multiply that answer by 2. So in the first step, finding the area of the sector, The radius is 10 and the angle is 6.6435. So the area of sector ABE will be equals to, so area of sector ABE is given by the formula half r squared theta. We know that the radius will be 10, so this will be half into 10 squared, and the angle is 0.6435. So multiplying 10 square, which is 100 by 0.6435 and dividing it by 2, the area of the sector will be equals to 32.175 centimeter squared. Now in the next step, finding the area of the triangle. So we can use the formula half AB sine C. So area of triangle, we can call the triangle ABX. So the area of triangle ABX, we can use half 1 upon 2 into AB sine of C. So the two lengths we'll take are 10 and 8, and the angle between them is 0.6435. So this will be equals to 1 upon 2 into 10 into 8 into sine of 0.6435. So 80 multiplied by sine of 0.6435 and then dividing this answer by 2. This will be equals to 23.99 centimeter squared. So the area of the triangle is 23.99 centimeters squared. Now finding the difference. So half of the shaded region will be equals to the area of the sector, which was 32.175. So 32.175 minus 23.99. So minus 32.175 minus 23.99, that is equals to 8.175 centimeters squared. So the total area for the shaded region will be equals to 2 times 8.175. So 2 times 8.175 will be equals to 16.35 centimeters squared. As we have to give our answer to 3 significant figures, so the final answer will be 16.4 centimeters squared. In question 6, points A 1, 1 and B 5, 9 lie on the curve 6y equals to 5x square minus 18x plus 19. In part 1, we have to show that the equation of the perpendicular bisector of AB is 2y equals to 13 minus x. Now to find the equation of the perpendicular bisector, first we'll have to find the gradient of AB. So finding the gradient of AB, that will be equals to y2 minus y1, which is 9 minus 1 upon x2 minus x1. That will be equals to 8 upon 4, which is equals to 2. Now the perpendicular bisector means it is at a right angle. So the gradient of the perpendicular bisector will be the negative reciprocal of 2. So that will be equals to minus 1 upon 2. To form the equation, we need a point on the line. So to find a point on the perpendicular bisector, we know that it passes through the midpoint of AB. The midpoint of AB will be equals to x1 plus x2 upon 2. So that will be 1 plus 5 upon 2, comma, y1 plus y2 upon 2. Simplifying this, we'll get the coordinates as 3, 5. Now finding the equation using y minus y1 equals to m into x minus x1. So that will be y minus 5 is equals to minus 1 upon 2 into x minus x1, which is 3. Cross multiplying, we'll get 2y minus 10 is equals to minus x plus 3. Taking 10 on the other side, we'll get 2y equals to minus x plus 3 plus 10, which will be equals to 2y equals to minus x plus 13. And this was the equation that we had to prove for the equation of the perpendicular bisector. In part 2, it says that the perpendicular bisector of AB meets the curve at C and D. We have to find by calculation the distance CD, giving our answer in the form square root of P upon Q. Now, in the first step, we'll have to solve the equation of the perpendicular bisector and the curve simultaneously to find the points of intersection, which will be C and D. Now, the equation of the curve was y equals to, it was 6y equals to So that was 6y equals to 5x square minus 18x plus 19. And the equation of the perpendicular bisector was 2y equals to 13 minus x. So we can write this as y equals to 13 minus x upon 2. Now substituting this into the equation of the curve, so that will be 6 into 13 minus x upon 2 equals to 5x squared minus 18x plus 19. 2 and 6 will cancel out, so this will become 3 into 13, which is 39, minus 3x is equals to 5x squared minus 18x plus 19. Now taking the 39 and the 3x on the other side, we will get 5x squared minus 18x plus 3x plus 19 minus 39 equals to 0. Simplifying this, we'll get 5x squared minus 15x, and 19 minus 39 will be a minus 20 equals to 0. Dividing the whole expression by 5, we will simplify it and write it as x squared minus 3x minus 4 equals to 0. Factorizing this, we'll get x minus 4 and x plus 1 equals to 0. So the two values of x will be x equals to 4 and x equals to minus 1. Once we have the x and the two values of x, we can find the y value by substituting these in the equation of the line. So as y was equals to 13 minus x upon 2, so this will be y equals to 13 minus 4 upon 2, and this will be y equals to 13 minus 1 upon 2. So 13 minus 4 is 9. 9 upon 2 will be equals to y equals to 4.5, and the other y coordinate will be 14 upon 2, which is 7. So the coordinates of C we can say are x coordinate is 4 and the y coordinate is 4.5. And for D, the x coordinate is minus 1 and the y coordinate is 7. Substituting this into the formula for the distance, which is x2 minus x1. So x2 we can take it as minus 1. So that will be minus 1 minus 4 whole squared. And for the y coordinate, that will be 7 minus 4.5. So that will be 7 y2 minus y1, 7 minus 4.5 whole squared, and this is a plus in between. So this will simplify and we can write it as 5 squared plus 2.5 whole squared. Now for 2.5, as we have to give our answer in the form square root of p upon q, so we can write this as 25 and we can write 2.5 as 5 upon 2 whole squared. Simplifying this, we'll get 25 plus 25 upon 4. Taking the LCM, we'll get square root of 100 plus 25. So the final answer will be 125 upon 4 for the distance CD. So if we have to give the values of P and Q as it is given over here, so the value of P will be 125 and the value of Q will be equals to 4. In question 7, part A, the diagram shows part of the curve y equals to a plus b sine of x. We have to find the values of the constants a and b. Now to understand this, what we have to first understand is that a basic sine curve, if let's say we are drawing a graph of y equals to sine x, it starts from x0 and y0 and goes on like this. Now, as this graph is for a plus b sine x, we can see that it has moved 2 units downwards. So this value of a, which represents a translation in the y direction, so this value of a will be equals to minus 2, as the graph has moved 2 units downwards. B is the amplitude, so the amplitude is basically the distance from the center till the top or from the center till the bottom. Now, as this will be the center point of the sine graph, the distance from this point to the highest point is 1. So the total distance will be 1 plus minus 1 till minus 2. So the value of B will be, the amplitude will be equals to positive 3. In part B1, we have to show that the equation sine plus 2 cos into 1 plus sine minus cos is equals to sine theta into 1 plus cos theta. So first expanding this, we'll get sine into 1, that will become sine, plus sine into sine squared, that will become sine squared, minus sine into cos, so that will be minus sine cos. Then multiplying 2 cos by 1, that will become 2 cos, plus 2 cos into sine will be 2 cos sine, and then 2 cos into cos will become minus 2 cos squared. And expanding the other side, that will become sine plus sine cos. Now we have to express this in the form 3 cos squared minus 2 cos minus 1 equals to 0. So we'll use the substitution sine squared plus cos squared equals to 1 in place of sine squared. So in the first step, we'll simplify this. So this sign on the left hand side and this side on the right hand side will cancel out. So on the left hand side, we'll have sine squared and minus sine cos plus 2 sine cos will become plus 1 sine cos. So this will be plus 1 sine cos. And then we have plus 2 cos minus 2 cos squared equals to sine cos. Now again, sine cos and sine cos on both the sides will cancel out. In place of the sine squared, we can replace it with 1 minus cos squared plus 2 cos minus 2 cos squared equals to, so there will be nothing over here, so this will be equals to 0. Minus cos squared minus 2 cos squared will be minus 3 cos squared plus 2 cos plus 1 equals to 0. We can rearrange this equation and write it as 3 cos squared minus 2 cos minus 1 equals to 0 as given in the question. In part 2, we have to solve the equation that was given previously for minus 180 till 180. Now we already converted it to cos form, which was 3 cos squared minus 2 cos minus 1 equals to 0. Factorizing this, we'll get, so using middle term breaking, this will be 3 cos squared minus 3 cos plus cos minus 1 equals to 0. Taking 3 cos common, this will become cos minus 1 plus taking 1 common, this will become cos minus 1 equal to 0. So we'll have cos minus 1 into 3 cos plus 1 equals to 0. So the two values of cos will be cos theta will be equals to 1 and cos theta will be equals to negative 1 upon 3. So cos inverse of 1, when we substitute that in the calculator, so cos inverse of 1 will be equals to 0. So one of the values of theta will be 0. Now finding cos inverse of 1 upon 3. So taking cos inverse of 1 upon 3, that will be equals to 70.53 degrees. Now as cos is negative, so we will be making cos in the negative quadrants of cos. So as the basic angle we got was equals to 70.53 degrees, we'll make this in the negative quadrant of cos. So this will become 70.53 degrees. So the angle theta will be 180 minus 70.53. So 180 minus 70.53 is equals to 109.46. So theta will be equals to 109.46 degrees. And as the range is from minus 180 till 180, so we'll have another value of theta in the negative, as with a negative value. So that will be minus 109.46. For angles, we have to give our answers to one decimal place. So the final answer for theta will be 0, 109.5 degrees and minus 109.5 degrees. In question 9, functions f and g are defined for x greater than 3 by f of x is 1 upon x squared minus 9 and g of x is 2x minus 3. In part 1, we have to find and simplify an expression for g of x. Now for g of x, it means that in the function g of x, the x is replaced by the function g of x. So g of x was 2x minus 3. In place of x, we'll again write 2x minus 3 minus 3. Simplifying this, we'll get 4x minus 6 minus 3. So g of x will be equals to 4x minus 9. In part 2, we have to find an expression for f inverse and state the domain of f inverse. So f of x was equals to 1 upon x squared minus 9. To find f inverse, we'll first write y in place of f of x. So that will be y equals to 1 upon x squared minus 9. Now exchanging the values of x and y, we will get x equals to 1 upon y squared minus 9. Making y the subject, we'll cross multiply. So we'll get y squared minus 9 is equals to 1 upon x. Taking 9 on the other side, this will become y squared is equals to 1 upon x plus 9. Finally, taking the square root, we'll get y equals to square root of 1 upon x plus 9. So the expression for f inverse of x will be equals to square root of 1 upon x plus 9. Now to find the domain of f inverse, we know that the domain of a function is basically the range of the other function. So to find the domain of f inverse, we basically need to find the range of values of x. What we know is that the range of f inverse will be the same as the domain of f of x. Now the domain of f is x is greater than 3, which means that the range of f inverse will also be greater than 3. So we can substitute greater than 3 in place of f inverse of x. So we can write this expression as 1 upon x plus 9 will be greater than, so this will be greater than 3, as the range of f inverse will also be greater than 3. So finding the value of x, will whole square both the sides. So whole square in both the sides will get 1 upon x plus 9 will be greater than 9. So 9 minus 9 will cancel. So we'll have 1 upon x as greater than 0, or x will be uh, taking the reciprocal of 1 upon x, so still that will be x will be greater than 0. So the domain of f inverse will be x is greater than 0. In part 3, we have to solve the equation f g of x is equals to 1 upon 7. Now we know that the function f of x was 1 upon x squared minus 9, and the function g of x was 2x minus 3. So to find f g of x, in the first step, we'll in place of x in the function f, we will write the function g. So that will be 2x minus 3 whole squared minus 9. And as we have to put it equals to 1 upon 7, so we can write this as 1 upon 2x minus 3 whole squared minus 9 will be equals to 1 upon 7. Now as we have to solve, we'll cross multiply. So that will become 2x minus 3 whole squared minus 9 will be equals to 7. Now taking 9 on the other side, this will become 2x minus 3 whole squared is equals to positive 16. Taking the square root of both the sides, we will get 2x minus 3 will be equals to plus minus 4. So taking 2x minus 3 equals to 4, we'll get x equals to 4 plus 3 upon 2. So that is 7 upon 2. And substituting x equals to minus 4. So that will be 2x minus 3 equals to minus 4. So minus 4 plus 3 is minus 1. So x will be equals to negative 1 upon 2. Now, as x has to be greater than 3, it means that the value of x in this case will only be 7 upon 2, as the values of x has to be greater than 3. In question 10, the diagram shows part of the curve y equals to 1 upon 2 bracket x power 4 minus 1. In part 1, we have to find the area of the shaded region. Now, to find the area of the shaded region, we'll have to integrate the expression for the equation of the curve, which is 1 upon 2 into x power 4 minus 1. And as the shaded region lies between the points x, 1 and 0, so the limits will be 1 and 0. Integrating x to the power 4 minus 1, we'll get 1 upon 2. This will become x power 5 upon 5 minus integrating 1, that will become an x. Now substituting the limits 1 and 0, so we'll get 1 upon 2 into 1 to the power 5 upon 5 minus 1. Substituting the lower limit, we'll get 1 upon 2 into 0 upon 5 minus 0. So this complete 0 upon 5 is 0, so this will become a 0. 1 upon 5 minus 1 is a minus 4 upon 5. 2 and minus 4 will cancel, so this will become minus 2 upon 5. As the area has to be positive, so we can give our final answer as positive 2 upon 5. In part 2, it says find the volume obtained when the shaded region is rotated through 360 degrees about the x-axis. So when we have to find the volume when a region is rotated through 360 degrees about the x-axis, the formula is pi into the integral of the y squared function. So the function was 1 upon 2 into x power 4 minus 1. So we'll first whole square this expression before integrating. and then apply the limits 1 and 0, and finally in the final answer we can add pi. So expanding x power 4 minus 1, that will become x power 8 minus, so that will be a squared minus 2ab, so that will be 2x to the power 4 plus 1, and we can keep the 1 upon 2 whole squared, which is 1 upon 4, we can keep it outside with pi. Now integrating x power 8, that will become x power 9 upon 9 minus integrating 2x power 4, so that will become 2x power 5 upon 5, and integrating 1 will get x. Now substituting the limits 1 and 0, we'll get in the first place when we substitute x equals to 1, so that will become 1 upon 9 minus 2 into 1 so 2 into 1 to the power 5 will be 2, so that will become 2 upon 5 plus 1. Taking the LCM of 9 and 5, this will become 45. So this will be 9 times 5. This will become 5 minus, this will multiply by 9. So this will also multiply by 9. And as the denominator over here was 1, so this will become 45. So this will also multiply by 45. So 5 minus 18 plus 45. When we substitute this in the calculator, so 5 minus 18 is minus 13, minus 13 plus 45 is 32. So this will become 32 upon 45. And when we substitute x equals to 0 into the expression, so this was when we substituted x equals to 1. When we substitute x equals to 0, so this will become 0 minus 0 plus 0. So that will become a 0. And this complete answer will multiply by 1 upon 4 pi. So this will be equals to 1 upon 4 pi multiplied by 32 upon 45. 4 and 32 will cancel. So we can write the final answer as 8 pi upon 45 for the volume of the shaded region. In part 3, we have to find the volume obtained when the shaded region is rotated through 360 degrees about the y-axis. Now, when we have to find the volume when a region is rotated through 360 degrees about the y-axis, we use the expression pi into the integral of the function x squared, and this will become dy, and the limits will be b and a, the upper limit and the lower limit. Now, the expression we had was y equals to 1 upon 2 into x to the power 4 minus 1. So in the first place, we'll have to make x our subject. So we can first write it as 2y is equals to x power 4 minus 1. So x power 4 will be equals to 2y plus 1. And as we need a expression for x squared, so that we'll take the square root on both the sides. Taking the square root on both the sides, we'll get x squared is equals to 2y plus 1 to the power 1 upon 2. And if you look at the expression, look at the diagram, the limits will be taken in terms of phi. So the limits will be 0 and minus 1 upon 2. So the limits will be 0 and minus 1 upon 2. And the expression will be 2y plus 1. The expression for x squared will be 2y plus 1 to the power 1 upon 2. Now integrating 2y plus 1 to the power 1 upon 2, we'll get 2y plus 1 to the power. So increasing 1 upon 2 by 1, that will become 3 upon 2. Dividing it by the new power 3 upon 2 and multiplying it by the derivative of 2y plus 1. So this will multiply by 2. So the final expression for the integral of x square will be 1 upon 3 into 2y plus 1 to the power 3 upon 2. Now substituting x equals to 0, initially we'll get 1 upon 3 into 2 into 0 plus 1 to the power 3 upon 2, and we subtract it from the other limit, which is minus 1 upon 2. So this will become 1 upon 3 bracket 2 into minus 1 upon 2 plus 1 to the power 3 upon 2. So 2 into minus 1 upon 2 will cancel. Minus 1 plus 1 is a 0. So this whole expression will become a 0. And over here we'll have 1 upon 3 into 1 to the power 3 upon 2, which is 1. And once we have integrated and subtracted the limit, so this will become a 0. We'll add pi to the final answer. So the final answer will be 1 upon 3 minus 0, which is 1 upon 3. And we'll add pi. So the final answer for the volume will be 1 upon 3 pi.